All right, I have started a card problem here. This is a combinations question. I want to show you how a lot of really hard questions that'll be on your next test can be solved with CC over C. Now, there's 52 cards total in the deck. And the next question you'd have to ask me is, if it's about cards you are being dealt, what do you think you'd need to know? Yes? How many am I going to deal you? Yeah, there's 5 card games, there's 2 card games. Like, how many of you have played Texas Hold'em before? A lot of you. That's 2 cards. Otherwise, it could be 5 cards. And I'm going to do a 5-card game this time. Next, why is there 2 different things on the top? Because do you get how a deck of cards is divided up into subgroups? There's clubs, spades, hearts, diamonds. There's queens and everything that's not a queen. There's aces, kings, queens, jacks. I mean, there's a lot of ways to subdivide it. So on the top, there's 2 C's, but there could be 3 or 4. Depends on the problem. I'm going to do one where there's 5 cards being dealt to you, and you want to see what's the probability you get 2 kings and 3 aces. That would be an amazing hand. 2 kings, 3 aces. Well, that's my subdivided part. Kings. And how many kings are there? This is a total. How many kings are there? 4. And I said I wanted to get 2. And then how many aces are there? And I said I wanted to get... Now, I want you to notice something here. Do you get... I only talked about kings and aces. What about all the other cards? Well, then you could say all the others, and all the other cards would add up to, let me do the math quick, it's 42 minus, or 52 minus the 4 was basically 52 minus 8, which would be 46, I think? No, 44, thank you. So there's 44 other cards, and I'm choosing how many of those? 0. I don't even need to do that, though, because that would just equal what anyways? 1. Because if you're choosing 0 of them, if you think about it, if you're going to choose 0 of them, there's only one way to do that. You just don't take any. There's only one way. Whereas this is a lot of ways. 4C3 is an actual number. This is an actual number. You multiply them and you divide by this, which is a ridiculously huge number. Now, do you think there are lots of hands out there where you get all 4 aces? Or sorry, 3 out of the 4 aces and 2 out of the 4 kings? There are not a lot. Considering this number is 2.5 million, the probability you'll get dealt that hand is extremely low. All right, now the big picture, what I set up there, watch what balances. That and that and that balance out what? The 52. And this and this and this balance out the 5. All right, I want you to set up one like that right now. So get into your iPad, turn it my way to show me if you're here or not onto the right page on the notes. My way. Turn it my way. Thank you. Most are there. Not everybody. Next time, go there faster. Unless you have the slowest iPad on the planet. All right, good. Kayam, do you have yours? All right, thank you. All right, since I'm recording, I try not to use whole names. All right, so this is just a... What is wrong with this picture? The hair looks a little crazy, but... Win a trip to the American Idol finale, or another fabulous prize.
Or another fabulous prize. Like the
One of my colleagues put this in there. Must be just to torture me. I don't know what's wrong with that picture. I can see, maybe it's the fact that she's not really holding the microphone. It's just like taped to her hand. Maybe that's it. There's no neck.
It's the hair.
The hair does look a little crazy, doesn't it? Like.
It has Domino's and Coca-Cola. It's just 7 fingers.
Oh, too many fingers. 1, 2, 3, 4, 5, 6 fingers. Yes. See? 1, 2, 3, 4, 5, and 6. All right. Thank you for catching that. There was actually more than one thing wrong in my opinion, but that's a big one. All right. Back to this. Would you please... Oh, wait. Before we do that, I want to try a CC over C problem with you and see if you can handle it. It's a card question. So right away you know what the bottom starts with. The whole deck of cards out there. I deal you 2 cards. What's the probability? It'll be what's called Big Slick. Anybody know what that is? It's an ace and a king. It's called Big Slick. It's a great start. Great starting hand. Ace is, of course, the best starting hand, but for right now, we're doing ace king. It's a CC over C kind of problem. All right, did you get that it was out of 52 C2 this time? Because that's the total. We're taking 2 out of a deck of 52. And then the CC part on the top, there was aces and kings. And I could say there's 4 aces and there's 4 kings. How many aces did I want? How many kings did I want? You multiply the top and divide by what's on the bottom. Now, if I wanted to, I could throw in that extra 44, right? Yeah, 44, choose 0, but it's not necessary. But it does make it balance nicely. Okay. How many of you had that set up correctly? Almost everybody. Okay, excellent. Now, I'm going to make it a little harder. Same problem in that I'm going to deal you 2 cards. What's the probability you're going to get exactly 1 king? I am dealing you 2 cards. What's the probability you're going to get exactly 1 king? Where did I tell you to start? On the bottom. Is there still 52 cards in this deck? And how many am I picking out? 2, so you should have at least known that. Okay, then what goes on the top? Well, I did say something about exactly 1 of something. 1, what was it again? King. So I'm going to label it king. Don't have to, but it's helpful. And now I have 4 kings in the deck, and I want 1 of them. If you do it like that, you get the answer wrong. Now, why? Forgot about the other card. You have to have the other card. Remember how I said it needs to balance? Does this add up to that? No, not even close. Does this add up to that? No, I'm missing 1. See? So you need that other C, which is not kings. And if you take 52 minus the 4, what do you get? 48. And then how many of the not kings? Or you could say everything else. You want 1 of those. There you go. And that's a number. It definitely matters. It makes a big difference. And now will it balance? That and that add up to that. Yay. And this and this add up to this. Raise your hand if you set it up correctly. That's most of you again. You guys are catching on fast. That's good. Okay. So let me stretch you. This isn't just cards. It's cookies. Same idea though. Think of it like cards. Instead of kings, this time I have peanut butter cookies. Instead of jacks, I have chocolate chip cookies. But I'll give you the specifics. I have 8 chocolate chip cookies. I have 6 peanut butter cookies. And I have 1 precious sugar cookie. My mom made really good sugar cookies. She had this measuring cup that was just perfect. It had this big, wide, flat bottom, and she would use that to squish out the little ball of dough. It's super thin, so they were like paper thin, and that made them really crunchy. Oh, fantastic sugar cookies. Thanks, Mom. All right. So do you get how this is sort of like a deck of cards? You add them all up, I have a total. It isn't 52 this time, it's 15. And it's subdivided into groups. Kind of like kings, queens, jacks, except it's peanut butter, chocolate chip, etc. Yes? I haven't told you that yet. All I've told you is what's in my bag of cookies. Okay? So in the bag of cookies, I have all of these things. And I reach into the bag, and what is the probability that I will get, if I take out 3 cookies, that they will all be peanut butter? Do a CC over C. So you should have said there are 15 and I'm going to choose out 3 and CC over C, so it must be multiple C's because I divided it up into parts, right? And there are the chocolate chip cookies, there are the peanut butter cookies, and then there are the sugar cookies. And so I go, how many chocolate chip did I have? 8. How many peanut butter did I have? 6. How many sugar cookies did I have? 1. How many did I actually pick out of the chocolate chip? None. How many peanut butter did I choose? 3, because I like peanut butter the best. Except for sugar, those are really good. Anyway, there we go. How many of you had it set up exactly correctly? All right. Wow, that's most everybody. Cool. If you rearrange the order, is that what you're asking? Oh, wait. Oh, I get. You said 9 choose 0 instead of these guys separately. Yes, totally okay and a good idea. Yes, that works great. Be the same answer. Think about it. Why? Because isn't this just equal to 1 and this is just equal to 1? And so would 9 choose 0 also be equal to 1? The main thing is you had to have the 6C3 on the top. Yes, sir?
Do you need to have the other ones at all?
Nope. If you had just had 6-3, the only bad thing is mine balances. That plus that adds up to that. And this and this and this adds up to this, and yours wouldn't balance. So the balancing thing makes you feel really confident that you're doing it right. I'll give you an example. Last hour, we had one where only one kid had it balance, but get the wrong answer. In other words, usually it's they get the wrong answer because the thing, if you check it, it won't balance. All right. One more like this, except it's even more obscure as far as being how to divide up your cards, so to speak, or your cookies. All right. Would you agree that when Apple manufactures their phones, some of them are not going to work? Every now and then they're going to give you a phone and the phone's just going to have some kind of bug. It's going to have an issue. Something went wrong in the manufacturing process. Okay? So let's say that out of 1,000 phones that they ship, typically 2 are defective. And it probably isn't something obvious like a cracked screen. It's probably something internal that you won't notice until you've bought it and you take it home. And there's going to be, there's some defective phones. All right. Now, what's the probability if you buy 3 phones that you'll get one of the defective ones? It's CC over C. You buy 3. What's the probability that 1 is defective? And that assumes, of course, that 2 are not defective. All right, where did I tell you to start? Bottom. So I recommend you start on the bottom and you figure out how many total you got and then how many you're taking. How many total do you have? 1,000. In case it wasn't clear, those 2 are part of the 1,000. It wasn't like 1,000 of these and 2 of those. It was out of 1,000 total, 2 are defective. So I am choosing to buy 3 of them. And then how do you break it into 2 parts? Yes? You got it. Defective and not defective. Then, of the defective ones, there are not 1,000. There's 2 defective ones, and you're choosing to get how many of them? 1. And then the not defective phones, there's not 1,000. is 998. You got it. And you're choosing to get how many not defective phones then? And that's a common mistake too. People just do this part because they see one defective phone and they think, well, I've got one defective phone here. But then that means you really got two not defective phones. All right. And also, if you only had the top part, do you get how it wouldn't balance? But mine balances. You understand that one? That's a tougher kind. Usually, when I did this first hour, only 2 kids got that one right. I've decided to give you a little example one first, and now I'm going to give you the real problem that I want you to do. Yes, sir. Question?
Are we ever not going to do letters on the test?
Not if you're asked to find big C kind of numbers. But I am just not going to promise you that you can use a calculator on the entire test. As in, like for instance, you would be expected to be able to do this by hand. On that note, why don't we give it a shot? Everybody try this one by hand. Both. Use factorials. Just in case you totally forgot, you start with 6 factorial on the top, remember? I'm going to pause while you're working on those. Record this. You should have said 6 minus 2 is 4 factorial, and then do you include an extra one of these on this kind or not? No, it's on the bottom kind that you do that. It would be 7 factorial for this one over 7 minus 3 factorial, which would be 4 factorial, and then you have an extra one of those, 3 factorial. Here's 6, 5, 4, 3, 2, 1, and it's all multiplied over 4, 3, 2, 1, all multiplied. Cancel, cancel. 5 times 6 is 30. Raise your hand if you had 30 on the top one. Good. And on the bottom one, 7, 6, 5, 4, 3, 2, 1 over 4, 3, 2, 1, 3, 2, 1, dot, 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 dot. Kind of fun. 4, 3, 2, 1, 4, 3, 2, 1. 3 times 2 is 6, canceling out the 6. See how fast that is? 7 times 5 is 35. Get good at canceling. Helps you a lot. Thank you. Okay, so that's how you do it by hand. Now, let's see if that amount of time was enough to make you forget how to do this. CC over C. Read it thoroughly. This is the problem that only 2 people got right last hour. But to be fair, I hadn't given them a practice one on it, so let's see how you do. Be done. Okay, so here's how you should have done it. You should have thought to yourself, CC over C, and what did server say to start with the bottom? How do you do the bottom? Well, how many are there? 75. How many are you choosing out of that 75? 10. You aren't taking out the defective ones. You are choosing the first 10 are being sold. 10 were chosen out. How many of you, that was your mistake? Wow, that's like a third of the class right there. Okay. Next one. CC over C. Okay, what am I dividing this into? Chocolate chip and peanut butter? No. What is it this time? Defective and not. Defective and not defective. And how many defectives are there? 4 are defective. 4. How many are not defective then? And don't say 75. 71. Think about it. Remember, it's supposed to balance. This and this makes this. All right, then the last part is how many do you want of each? How many out of these 10, remember it's got to add up to 10, how many are defective out of the 10? 1 of the first 10 is defective, 1, and therefore how many are not defective? 9. So how many of you had that right? Raise your hand if you did. All right, and what is the decimal that it comes out to? 359? All right, so 359 was the most common answer at least. It was, but unfortunately, I'm sure it can be done differently. Why don't you tell me how you did it? Okay. On the bottom or?
Yeah.
Okay. I don't even want to go there because it may have come out to the right answer, but that's not the way that I need you to do them. So do you get how that works? Sometimes you can do a problem wrong and yet get the right answer. And I just don't want to show you a way that might confuse you for the future. There were 10 taken out. That's what should be on the bottom. Okay. All right, so let's do one more. Now that you saw that last example, this is a lot like it. I'm hoping that we get up to like 85% of you get it right this time, now that you saw the other one get done. A business receives 120 printers. Okay, give that one a shot. So here we go. After I gave you a little pause there to do it, I'm hoping that you knew to start with the bottom, and I'm hoping you knew that there was CC over C, and I'm hoping you knew that there were 120 printers and you were picking out how many total? 1 defective and 4 non-defective. That's a total of 5. Raise your hand if you started with the bottom correctly. Good. Then on the top it's CC, and then it was even nicer than the other because it tells you specifically 1 defective and 4 non-defective. So here's defective and non-defective. And he gets 1 of those and 4 of these. And then how many are there that are defective? 3 are defective. That's what it's out of. And then how many are not defective? Don't say 120. 117. Now, if you had that wrong, you probably could have caught it by noticing that that and that have to add to that. And this have to add to this. How many of yours balanced at least? Even if it was wrong, it balanced. Okay, good. Now, if you didn't have it balanced, notice that. You needed to balance. The CC over C thing, that really works well if you watch for balance. All right, for the decimal, I don't know. Who did it this way and has a decimal? What? 117. Raise your hand if you think it's 117, and those are the same people. All right, good. All right. If you're going to put this in, I would make sure you put in parentheses on the top. Did you know that? Because if you're going to put it in all at once, it has to calculate the top part first, and if you don't do it in the right order, it's kind of like this. If you put this into the calculator, your calculator thinks you mean 1 plus 4 divided by 5. So I'll divide 4 divided by 5 first, and then I will go back and add 1. And you don't want it to do that, right? So if you're ever doing a fraction that's got more than one thing on top, put a parenthesis around it. And then you'll have to do this first, and then you'll divide by 5. All right. So that's your worksheet right there, 12.6 worksheet B. It's just like we just did. There's going to be a lot of CC over C kind of questions, but I'll warn you, not all of them are probability today. So remember, the CC over C thing, those are probabilities. That's why you have the big fraction. When they just say, how many ways can this happen? Just one thing you don't need to divide by on the bottom. All right. That's all I got for you for today.